Hello, my name is Rich Dasterley and this is my presentation for CO6008, my innovation project, which was creating a voice-controlled application, email application. So my aims and objectives for this project. The objective was to develop an application that will enable the user to access their email and have them read aloud. Using voice recognition software, the user will be able to instruct the application in a variety of different ways, allowing for the desired response. The objectives of the project are to research architectural design patterns of software to develop a working, secure, and an economical product. Research object-oriented programming to develop an understanding of modern programming techniques needed to make efficient software, to assess the need for such a product in today's current market, exploring if there will be an impact on employee productivity across all working sectors, as well as what kind of impact a more accessible product could have for people suffering from vision difficulties. A business case was developed for the project. The business case followed PRINCE2, which is a project management model that covers feasibility, business benefits, business downsides, timescale of the project costs, an investment appraisal, and the major risks of doing the project. The design process. Software can be built in numerous ways. When developing an application, it is vital to select a software architecture that best complements the aims and requirements of the application that you are constructing. For my application, two software architectures were considered and explored: the monolithic architecture and the microservice architecture. Monolithic design architecture. The monolithic design pattern is a traditional method of software design. It is where an application consists of three main parts, including the user interface, the business logic, and the database for the system. Advantages to the monolithic design are that it's a traditional approach to software development. Software developing tools such as IDEs are made specifically for the development of monolithic applications, making it more suited to building them, and it also makes testing easier as all the code is within one file. Microservices. The microservice architecture are a way of building softwares that consist of splitting the application into separate modules that are then called using an API. Microservices has advantages such as making continuous delivery possible, making the software and updates easier to deploy. Each service is independent of the next, allowing for developers to change a specific service without affecting the whole application. As each service is independent within the microservice architecture, small automated tests can be implemented, making it quicker and easier for them to run. As each service is independent of each microservice is independent of the overall application, it allows for easy editing or changing of the system. Building a system following a microservice architecture means that faults may be isolated more easily. If one service is down due to a bug or other failure, all the other services will be able to handle requests. Microservices do come with some disadvantages. Distributed systems are complex and difficult to manage, with the possibility that a microservice could be handling millions of requests per second. High latency could become an issue. Network and hardware failures could also have a big impact on a microservice and take the application offline. Each service also has its own database, making it difficult for things like transaction applications, because instead of just having one central database, a customer might be located in one, the cost of a product might be located in another, so on and so forth. Ethical, privacy and security concerns are also consideration for this project. For users' privacy, the application was designed in a way that follows the UK Data Protection Law, or Act. It is the UK's version of GDPR, the General Data Protection Regulation Act, which was made law by the European Government. GDPR and Data Protection Act both state that a user must be greeted with a disclosure informing them what data is being collected on them and an option to opt out of having certain data or any data at all stored on them. GDPR also states that a user's information must be informed in a timely manner should a data breach were to take place, as the only personal data needed from a user for this application would be the user's email address. There is no need to request the user's name, physical address, or any other information about them. The planning stage. The initial steps in the implementation were to plan how the application would look and how it would function. The main focus was that the application would require as little physical user interaction as possible, as the goal is to talk to the application and have it respond back to the user. Software development lifecycle. The chosen software development lifecycle for this project was Agile. Agile's model split the work into small increments or sprints, with each sprint focusing on one aspect of the application. From planning all the way to completion, the application was split into 2 sprints, focusing one on a UI implementation and the other focusing on the back-end functionality. Software implementation. Windows 10 was the chosen OS for the application to be developed on, and the application was developed using Python 3.5. Graphical user interface implementation. The user interface was first designed on paper. The prototyping software Balsamiq was used to create wireframes of the hand-drawn designs. These wireframes were then refined until a working prototype was developed. From there, this user interface was developed in Python using Tinker. Functionality. To be able to communicate with the user's email provider service and be able to retrieve sent emails, the Internet Message Access Protocol, or IMAP, needs to be set up. For this, an IMAP client was chosen over the standard module that comes with Python, as it just had better usability and easier to use for this scenario. The IMAP protocol handles how emails should be formatted, encrypted and pulled from the mail server. Each of the major mail providers maintains their own domain for IMAP to request to. The login function takes care of this within the application, which is in the user interface, and applies logic which first checks the email provider they are wishing to connect with and then selects the relevant domain name for that email provider. Voice recognition for this application. The next challenge was to come up with a solution of how the application would handle speech recognition. Speech is decoded into text by matching groups of vectors to one or more phonemes. The first step in implementing this section is to call the recognizer class. As the name suggests, this allows for speech to be recognized as well as the chosen API to be applied to all the classes. In this instance, we use the Google recognizer because the Google library is known to be reliant and it's very well maintained, so it just made sense for it to be Google's API that we called within the code. Once this is set up, the program needs to be told to listen to the microphone for any audio that is being passed in. Once it detects what the audio is, it then checks across. So once it's logged in and it has pulled the email folders, it then checks to see if the user says inbox or junk or deleted, for example. And when it recognizes one of those flags, it will then move to that folder and it will then read that folder to the user, or the emails that are within that folder to the user. For this, email playback functionality was developed. This was the final function that I developed for this. It took 3 separate variables. It split up the message into 3 separate parts. So the sender, the subject line of the email, and the actual body of the email. And then from there, what I did was to create a file that contained all three elements, which were then read back to the user. And if we go to the demo here, I will just demonstrate this for you. Hello, my name is Richard Astley, and this is a demo for my talking voice-controlled email application for my dissertation and module CO6008. When the user runs the application, this, which is the login screen, consists of a field for their email address, their password, and their email provider. They need to specify their email provider because of how each email provider has its own IMAP address to speak to the IMAP server, which is handled here. So Google, for example, is imap.gmail.com. Outlook is imap-mail.outlook.com. And Yahoo is imap.mail.yahoo.com. So this is just to make sure that the user chooses the correct one, so the right IMAP message is sent to the server. For today's demo, we're going to be using Outlook. If, for example, the user didn't get it right or didn't specify, we go to login here. We'll get an arrow down low. Authentication failed, invalid credentials, failure. So if we then change this to Outlook, this will now log us in. We'll be able to request the application to read our inbox. Let's do that. And then if we say inbox,
Richard Sterling, our.sterling@gmail.com. This is the subject line of the email. This is the body of the email /our/n.
So what we heard there was the application reading the inbox of this email account. So if we click into here, we can see that it read the subject line of the email, told us who the email was from, the name and address, and it tells us the body of the email. As you can see in this account, there's also a junk email. So what we will do now is we'll request the application to read us this junk email, which consists of the same thing again. This is a subject line for a junk email, tell us the sender, and it will tell us the body. Okay, this time we will ask it to read the junk mail. Junk. Junk.
Richard Sterling, our.sterling@gmail.com. This is a subject line for a junk email. This is the body of a junk email /our/n.
And as you can see there as well, it also handled that the user didn't recognize the speech, so they got another attempt. This has been my demonstration for my dissertation application. Thank you for watching. Goodbye. Thank you for watching our demo. Next, it was the testing stage. The next step, testing was done to validate these requirements were met and to resolve any bugs or unwanted behavior of the application. The testing was done in two phases. The first test case was drawn up and followed by the developer to highlight any issues or oversights that I may have missed. The second phase of testing was user testing. I was able to do a small amount of user testing by making a test script and asking friends and family to test it, but unfortunately due to the lockdown and the COVID situation, I wasn't able to get as much testing done as I'd have liked, because I wasn't able to get the application around. But I did get some good feedback from the user testing, so it was still worthwhile conducting the user testing even due to the difficulties of the present climate. Evaluation and future work. So overall, the project achieved the majority of its goals. The final application allowing for the users to sign into their email client of choice, request their inboxes to be read, the junk mail to be read, deleted emails to be read. Further, in the future, the application can be developed to look much cleaner. The UI is very basic and very clunky, and to have a little bit more interaction, such as flagging emails and deleting emails just with the use of voice. this has been my presentation. I'm Richard Astley, and thank you for listening.